Hello everybody and welcome to my YouTube channel. In this video we're going to consider the naming of coordination compounds. So coordination compounds are compounds that are formed when metal and ligand are are bound together. So now we have some rules for naming them. So the first rule says that you should name the positive part before the negative part. So let's say we have this coordination compound. Okay, so this is an ionic compound and the structure is nickel NH3 2. Okay, and we have 2 of this Cl. Now Cl is Cl minus, so we're having 2 Cl minus, so we have -2 here. So to balance it, the other side must have +2 because overall this complex has no charge. So what this rule is talking about, the first rule is saying that we should name the positive end first before the negative end. Just like the ionic compound of sodium chloride, we'll be having sodium plus and Cl minus. So we have to name the positive first before we name the negative. So it won't be chloride sodium, but rather it will be sodium chloride. You name the positive end first before you name the negative end. That is what that rule is talking about, the first one. Now the second one is saying that we should name the ligand first before we name the metal. So say for instance we're having nickel and carbonyl bonded together. So what's saying is that we should name this carbonyl first before you name the nickel. Okay, this one is not really an ionic compound, it's just like a complex like that, a coordination compound with CO. CO is a ligand, okay, bonded to a metal. So this is just not really an ionic compound, so it's actually a coordination compound. So you have to name the ligand first before you mention the name of that central metal ion. So that's what the second rule is talking about. And there are some ligands that have special names like H2O. Okay, you call it aqua or you call it aqua. And we have NO as well. It is called, normally it should be nitrogen 2 oxide, right? But you won't call it that, you rather call it NitroCO. And we have CO2 that should be carbon 2 oxide, but we rather call it carbonyl. We also have the last one, which is the NH3. Instead of you to call it ammonia, you call it amine. But to distinguish the difference from the normal amine that we have in organic chemistry, RNH2, which is just AMINE. Just one M, then you put 2 MA to signify that it's NH3 in coordination compounds. That's the third rule. Then the next one is that anionic ligands are to end their name with O. So you end their name with O. Like CO now. CO is just carbonyl. It's not really an anionic ligand. Anionic ligand are the ligands that having negative charge, like OH minus, SO4 2 minus, and their likes. You can have Br minus too. So what they are saying is that you should end their name with O, suffix O. So this one becomes chloro. So this become chloro, this become bromo, this become hydroxo. Okay, and this becomes sulfato. It was sulfate before, so it becomes sulfato. So that's it. And the next one says that you should, if you have an anionic complex now, a complex that is anionic, you should name the metal, you should end the metal name with ATE, suffix ATE. Okay, and you must name it in its Latin name. That is what that one is talking about. Okay, so say for instance you're having this compound here, CuCl4 2 minus. Normally, if you want to name it, the name of this should be copper. But because the whole complex is having negative charge, it won't be copper, it will be copperate. Because in Latin, the name of copper is coprum. Okay, it's coprum. So now that is having negative charge, it will be copperate. You just remove the and you put 8. So the name of copper in this compound will be cuprate, like that. So after you've named it and it reached the turn of copper to name it, you just have to put cuprate instead of copper. Okay. And for iron too, instead of you to call it iron, you call it ferrite. Ferrite. Okay. So there are many, like that. So that we're going to come across when naming the compounds. And this last rule is talking about when you have more than one ligand of the same type. If you have more than one ligand of the same type, you put di for 2. Okay, so for instance, in the first compound that we had, so we have NH3 2. So in this case, it will be diamine. Okay, so like that. If you're having 2 chloro, it will be dichloro, like that. But there are some ligands that have some multiple name, some multiple prefix in their name. So you have to put, for 2 of them you put bis and you put them in brackets. Okay, for 3 of them you put tris in brackets. For 4 you put tetra keys. Okay, and for 6 you put hexa keys, like that. What I'm talking about is like ethylene diamine now. Ethylene diamine, I will short as EN. It is a ligand itself, but because in its name it's having di. Okay, if you want to, maybe if you're not having 2 of these EN in a compound, instead of you to call it diethylene diamine, you rather call it bis ethylene diamine. That is what that rule is talking about. So we are going to see more of this when we start naming them. So now let's look at some examples. Let's start with some examples. So for instance, we are having this compound PT NH3 4 Br2. For you to have bromine here, it's showing that it's an ionic compound. So we have Bt NH3 4, then we have Br, we have 2 of that, and it's having negative, so we must put 2 plus here too. Now we have to name the positive end because we're having 2 ends now. We have the positive and the negative, so we have to name the positive first. So now to name the positive, it is a complex in its own. It's a coordination compound on its own. So what you have to do here is that the rule for naming coordination compound is that we should name the ligand first before we name the metal. Okay. So the ligand here is amine, and we're having 4 of that. So because amine, it doesn't have like di or whatever in it, so you just have to put tetra for 4. So that would be tetra amine. Okay, then you name the metal, which is just platinum. So it should not be platinate because the charge is positive. If it is negative charge, that is a negative complex, so it will be having negative. It will be having 8 at the end, so it will be platinate. Because it's having positive, it will retain its name, so it will be platinum. And anytime you are measuring a compound, you are measuring a metal, you must put its oxidation state. So to calculate the oxidation state, it means that when you add the oxidation state of this and this, you should get +2. So you don't know for platinum, let's calculate X plus that of ammonia will be 0. So 0 times 4, okay, will give us +2. So the answer will be equal to 2, like that. So it will be platinum 2. So that's how to name this compound. Now let's look at another example. So let's say we have COEN3 Cl3. So now we should have COEN3 and we should have Cl, 3 of them minus. Okay, let me just separate them a bit. So we have 3 Cl minus. So this should have 3 plus. So you have to name the positive end before the negative end. Now this, you have to name the ligand first before you name the metal. So En is abbreviated as ethylene diamine. So that's the ligand. So and we have 3 of them. So instead of you to call it ethylene diamine, you won't say that. You rather say tris. Okay, as I wrote it the other time, you just say tris ethylene diamine. Okay, then you name this, which is just cobalt. Then the oxidation state of cobalt here will be X plus. So for this ethylene diamine, it is 0 times 3, then equal 3 because the charge. So that will be S equal 3. So we have cobalt 3 like that. So this is how to name this compound. Now that's not all. That is not all. Okay, you have to name these parts too. So this is just the positive part. So the negative part will now be what? Will now be just chloride. You know, if you want to name sodium too, sodium chloride. So this part will be chloride, not chloro. If it is acting in the sphere, you just call it chloro. But if it is outside, you call it chloride. So this one will now be tris ethylene diamine cobaltary chloride. Okay, so that's how to name this compound. I think I forgot to name the bromide part in the last example. So if you want to name it, this is PT-NH3-4Br2. So which I said will be PT-NH3-4, Br minus. We have 2 of that, 2 plus. So this should be tetraamine platinum 2, then you have bromide. So that should be the name. Tetraamine platinum 2 bromide. So that should be the name. Please try and rectify that. So another example here is K2FeCN6. So to name this, we're having potassium and it is positive charge. So that will be 2 of this potassium that is positive charge, and to the overall charge is now negative, is now 0, right? So to make it balance, you just put 2 minus A2 because you have 2 positive charge here. Now you name the positive end first. So that will be potassium. Then you now name this ligand, which is negative. Now to name the ligand, normally you have to name, you name the complex, the whole complex. So to name it, you have to name the ligand first. So the ligand here is just CN, which is cyano. It should be cyanide, right? CN should be cyanide, but it should be cyano. Okay, it should be cyano, right? So now you have to have this named. So that will be cyano. And we have 6 of that, so that will be hexa. And don't forget, because cyano does not have maybe like di or whatever, so it should just be normal hexa because it's a monodentate ligand. So hexa cyano, you now put ferrite. So because it's having negative, so the metal here will be having 8 at the part of its name. So that will be ferrite. So what will now be the oxidation state of this ferrite? So you have to calculate that. So that will be X. Then this one will be plus, in bracket of cyano is having -1. So that will be -1 times 6 equal -2. So that will be X minus 6 equal -2. X will be equal to 6 minus 2. That will be equal to 4. So that will be hexacyanoferrate 4. Okay, then you join it with this name. So you name the first one first, which is potassium hexacyanoferrate 4. So that's how to name this compound.